There is nothing more terrifying than black holes when you think about space. These bad boys will suck in anything that comes close to them, including massive stars, dust, and spaceships, among other things. They are powerful enough to even suck in light. However, the opposite of these black holes exists, and they're not any friendlier. Their opposite siblings are known as white holes. The discovery of white holes set off a whole new excitement in the astronomy community. But the question is, what exactly are these white holes? How did they come to be? Are they similar to black holes, or are they completely different? Hello everyone, and welcome back to our channel. Join us as we try to find out what these white holes that astronomers have recently discovered really are. But before we continue, make sure to subscribe to our channel for more videos like this one and even better. And with that, let's have a look at these white holes. Unless you want to end up inside a black hole, don't get too close to it. The most common black holes are known as stellar black holes. They are formed when the center of a very massive star collapses in upon itself. This mostly leads to a supernova, or basically an exploding star that blasts parts of the star into space. According to scientists, supermassive black holes form simultaneously with the galaxies in which they are found. This means that even the Milky Way, which is the galaxy that we're in, also has a black hole at its core. The size of these supermassive black holes entirely depends on the size and mass of their host galaxies. The Milky Way's black hole is known as the Sagittarius A. It is powerful enough to swallow up to 4 million of our suns, and it would still have enough room for more. If it were not for the fact that we are far enough, we could have been swallowed already. Because of the huge amount of matter pressed into a tiny space, black holes exert a strong gravitational pull. This force is mostly felt by the objects that are near the black hole. The compression of this matter mostly takes place at the end of a star's life. So, does this mean that it is an exploding star? Exactly. A star dies by exploding. If you are now worried that the sun could become a black hole one day, then don't be. The sun will never become a black hole. This is simply because it is not large enough. The most it can become is a red giant star, after which it could transform into a glowing ring of gas, which is termed a planetary nebula. After all that, the only thing that would be left of the sun is a cooling white dwarf star. With all that, how are black holes detected? Unlike a star, you cannot see a black hole with the naked eye. Instead, scientists discover them with the help of their effect on their surroundings. The first way to discover a black hole is by the influence of its gravitational force. For example, if you look at the Milky Way, you will notice that there is an empty spot around which all the stars circle. It is as if they are orbiting a really dense mass. That mass is the black hole. Another way of finding a black hole is by observing the matter falling into the black hole. As the matter is sucked into the black hole, it mostly settles into a disk around the black hole. Some of the energy that is not sucked in is turned into light, which we now see using X-rays. But here's something to think about. What would happen if you reversed a black hole? If you think about deep space, you will definitely be scared. There are a lot of things going on in deep space all at once. But as black holes suck up everything that comes close to them, white holes do the complete opposite. Theoretically speaking, a white hole is the exact opposite of a black hole. As previously stated, anything that comes close to the black hole cannot escape its powerful gravitational pull. In the same way, a white hole is a region where space-time flows outwards. According to the theories concerning this, white holes are said to have an event horizon radius that prohibits the entry of any matter, which includes light. Because of this, white holes are said to expel light, which radiates at levels that are equal to the force of a black hole. This theory of white holes was born from a mathematical fascination with black holes. One of the forefathers of science, Albert Einstein, discovered that even though accelerating observers experience time differently, that does not apply to non-accelerating observers when moving at a constant speed or stationary. He also concluded that the speed of light was independent of all motion. After making these discoveries in 1905, he went on to publish his theory of general relativity. This theory says that objects with mass have gravity, and this gravity is a distortion of time and space instead of being an actual physical force. Einstein's field equations were further expanded on by Carl Schwarzschild. He used these equations to solve the equation of mass in empty spacetime, or an area that is completely void of all matter. This led to the Schwarzschild metric. The equation itself is not a simple one. However, it is the greatest mathematical representation of a black hole. However, Schwarzschild's black hole is one that has no charge or change, and it is referred to as an eternal black hole. This black hole has not changed in size and has always existed. Beyond the event horizon, all events happen infinitely far in the future. This means that an outside observer would see these events as if they had never happened. According to the Schwarzschild metric, in the idealized black hole, space becomes time and time becomes space. This swaps their roles so that the singularity of the black hole is in some inevitable future time instead of a place. So if you try to reverse time in a real black hole, you just might see a dying star. However, if you try reversing an eternal black hole, you get a white hole. But where exactly do these white holes come from? Several theories suggest that black holes and white holes are, in fact, connected. They suggest that matter and energy that fall into a black hole could potentially emerge from a white hole somewhere else in the cosmos or another universe. Carlo Rovelli in France, along with his colleagues, made the suggestion that black holes and white holes might be connected in another way. They hypothesized that if a black hole dies, a white hole will be born. Stephen Hawking, a theoretical physicist, calculated that all black holes should evaporate mass by emitting radiation. Black holes that lose more mass than they gain are expected to shrink and ultimately vanish. However, according to Rovelli and his colleagues, shrinking black holes could not disappear if the fabric of space and time were quantum, meaning they were made of individual quantities called quanta. Space-time is a quantum that aims to bring general relativity together. This explains the nature of gravity with quantum mechanics, which can describe the behaviors of all the known particles into a single theory, which can then explain the forces of the universe. According to a study conducted by Rovelli and his colleagues in 2014, if a black hole evaporated to a degree where it could not shrink any further, mainly because space-time could not be squeezed into anything smaller, the dying black hole would rebound into a white hole. However, the process from a black hole to a white hole is not fast. According to Rovelli, a black hole with a mass equal to the Sun would take a quadrillion times the universe's current age to convert into a white hole. According to this theory, unlike black holes that result from dying stars, white holes are not created directly. Other theories place the creation of white holes in a similar fashion to the Big Bang. This is because of the random density fluctuations in the hot, rapidly newborn universe. According to this thought train, areas where these fluctuations concentrated matter together could have collapsed to form black holes. These primordial black holes would end up being smaller than stellar black holes, and they're the ones that could have died to create white holes within the lifetime of the universe. Rovelli and his colleagues claim that white holes are just theoretical. However, that is not enough to dismiss them, given that black holes were once a theory, and since then, they've been proven to exist and have also been found to exist all over our observable universe. What do you think of white holes? Do you think they exist, or is it just a theory? Let us know in the comments section below. Also, before you leave, make sure you leave a like and subscribe to our channel for more amazing videos. Thanks for watching.